Hi, everybody. This is Paul Speciali, and this is Scality's podcast, episode number 3. As before, I am joined by my colleague, Giorgio Regni.
Hey, everybody.
Giorgio is the Chief Technology Officer and one of the original founders of Scality. And we together have been fortunate enough to work here for, in Giorgio's case, 15 years, in my case, almost a dozen years. And as with every week, we try to bring an interesting and relevant topic to the forefront. Today, we would like to discuss one of the sessions that we participated in an event held by Supermicro. Supermicro calls this the Open Storage Summit. It's actually the 6th year that they've held this. And what they do is they invite representatives from some high-profile companies. You'll see some of the names on the panels that we participated with, but these expert speakers participate. We provide our views to topics ranging from AI to cloud and what's happening across the tech industry. Giorgio was actually our representative in one of the sessions entitled Tier Storage for AI Workloads. This had panelists from the host company, Supermicro, but also from NVIDIA, Weka, Kioxia, and again, Giorgio was our representative. This was hosted by theCUBE and Rob Strachet. And I guess, Giorgio, it would be perfect for you to tell us what was the nature of this discussion.
Yeah, and I think the anecdote is you were supposed to go but couldn't, so I went last minute.
That's right.
It was a great fit because I know Rob and the team were there. Was pretty great to be there.
Yeah.
Yeah, so it was interesting to talk with flash vendors, drive vendors, customers, and NVIDIA and Intel all in the same place, right?
Right.
So I think for today, what I wanted to do is maybe take some slides from our partners.
Sure.
And talk about the highlights and looking at it from the object point of view.
Okay.
So that's a slide from NVIDIA, John Kim, a great guy. So when you look at the hierarchy of storage, it's a pyramid because the bottom is much more capacity. And as you go up, we're talking about gigabytes. At the bottom, we're talking about exabytes, right? To give you an order of magnitude. And the hard drives is still the biggest capacity, right? So at the bottom, network hard drives. What are you going to store there? So it's all the logs. You know, when anything happens, you want to keep a trace of it because you want to be able to go back in time and see whatever the model was at the time. So you look at the logs, history of every prompt, all the outputs, all the old models. So in 10 years from now, maybe not, but maybe somebody wants to go, oh, give me the model as it was a year ago because it turns out it was better, right? That happens to everybody in AI where you think you improve, but maybe you haven't. And so you have to go back in time and recheck. So all of that gets stored and that's a lot of capacity and looking at hard drives. Then as you go up, you see that it's more and more not the raw data itself, but a version of the data that has been processed. So it could have been vectorized. So vectorized is you put it into a space that the model understands. The model doesn't understand an image. He understands a vector that tells it what's in the image.
Yeah.
And so that's vector databases, inactive models that you still want to get fresh. That's going to go on Flash. And it doesn't matter if it's object or file. It could be an object store using Flash. As you go up, you get closer to the actual machine that gets the GPU. So it's not network anymore. Now you go into local. And you have local storage where you're going to have, when you prompt an LLM and the prompt starts the same.
Yep.
You don't want to have to redo all the parsing and understanding of a prompt. So there's a lot of caching happening. So that's what's called the KV cache. So you're going to cache a lot of information locally on the GPU and all the temporary logs. If you were to log directly into the network hard drive, it will slow down the entire platform. So you're basically having to log locally and then store into the network devices. So that's all happening on local flash.
Very interesting. It sounds like it's clear now, Giorgio, that tiering the storage for these kind of workloads is the right approach, and NVIDIA even seems to agree.
It is. And tiering, sometimes the data never touches the other tiers, right? It's just you use the right tier for the right data at any point in time. And then you get into the CPU memory, which is one of the fastest piece in the entire equation. That can be big, that can be terabytes, right? And then you go into the GPU memory, the HBM, and now you're looking at gigabytes, like 32, maybe 128 gigabytes, but you're not talking about terabytes anymore. And you have to be very careful of what you put in that cache. And the model goes into that memory, so you already consume a big chunk of it.
Got it. Okay. Still an impressive space for GPU memory.
Yeah.
So it sounds like object storage is starting to surface in this world as well.
So not starting, it's the origin, right? So
Mm-hmm.
without object, you don't have AI.
Mm-hmm.
And as you can see, the data lake, which is where you put all your assets, all your data, is an object storage platform. That's an NVIDIA slide. It's not a Scality slide.
Yep.
You see object storage. So on Amazon, it's Amazon S3. On
Mm-hmm.
Google, it's GCS. On Azure, it's Azure Blob. But it starts in the object store.
Got it.
Then you move what you need either to high performance object, you see on the right side, or to high
Mm-hmm.
performance file, depending on how modern your stack is.
Yep.
And then you're going to do the training that you need to do.
Okay. So object storage really as this key repo, like you said, it started with data lakes, and now we're moving into these very interesting high performance arenas. There was also Weka on the panel, I understand, and they did share something that we have here on a slide as well.
Yeah. So as we look at the market the same way that they do, it's an ecosystem of ISVs. So you see all the ISVs at the top that are being used in AI. And a lot of these workloads need very low latency. So you're looking at InfiniBand, NVMe over Fabric, 100 gigabits Ethernet.
Mm-hmm.
Their neural mesh product gives you that namespace across all these applications. And at the bottom, which is not a negative thing, but as the foundation, it's an object storage system.
Right.
That has all the data in it and that scale the capacity. So you can imagine having a fixed size, all flash Weka tier.
Yep.
And have the object store in the back that gives you all the capacity that you need.
Very good. And we've done a very optimal connector between Weka and our product Scality Ring.
Yep. We move whatever Weka doesn't need to get the maximum performance out of our system.
Right. Sets up kind of this ideal tier 0, tier 1.
Yes.
Okay, very good. You mentioned all of these ISVs that are now relevant here. I know that we've done a lot of certification, and it's already several dozen type of ISVs that are part of this pipeline. So It seems to be a key part of it. A little bit about performance, perhaps, on the different qualities of storage?
Yeah, so even in the object store, there's tiering. There's different tiers, right?
Right.
So you see this diagram at the bottom, you see the capacity. So going from terabytes to exabytes, and the latency, the more up you are, the smaller the latency, right? So Flash, which is WinXP for us, that is going to support a Q object, the RDMA over Fabric S3 interface to GPUs, right? And that's the lowest latency in our system. And you're looking at microseconds latency. Then you have WinXP on Flash, which you're going to use the S3 API to access it, no Q object. And this one can grow to hundreds of petabytes or multiple hundreds of petabytes. It could grow bigger, then it's a question of economics, are we willing to spend that much on this layer? And then we give you the choice. We don't force you. So you have a choice to use hard drives if you want to as well. That's a typical Ring S3. And now with hard drive, we're comfortable about the economics. And we know that you can go to exabytes and it still makes sense. It's still much cheaper than cloud, and it's still much more available and durable than other solutions using drives. And if you need to archive or for compliance reasons, you need to store a copy on a different system, then you can also tier to tape with our Ring long-term storage solution.
Okay, very good. So it's sort of this end-to-end data lifecycle on the optimal storage media, even within the object store.
Yeah. So we are really, as a company, we love the hardware, yet we want to make sure you can choose whatever hardware you need. And we support both the fastest flash, the high density flash with QLC, the drives and tape, all on the same platform.
Yeah, it's fascinating, right? Because 15 years ago, the original premise of software-defined storage was to decouple from the hardware, give people choice. But now 15 years later with AI, it's still great to have this because now we have all of these different qualities of flash as well. So it really lets you optimize for the different parts of the workload. All right. Well, thanks, Giorgio. With that, I'm just going to wrap up by providing a little bit more information. There's a few pointers here. Supermicro Open Summit is something that streams for a week here in August of 2025. All of the videos, all of the sessions are available on replay. They were hosted by theCUBE, as I mentioned. Here's the URL where you can find all of the recordings, including this one, the one that we talked about for tiered storage for AI. I want to promote Supermicro here as well, the YouTube channel. They were the hosts and they were wonderful in terms of bringing us in and all the other sponsors. And then for those of you that are interested in our solutions for all flash and for HDD for AI, there's a link here to Scality Ring and Ring XP. And we talk a little bit more about how we fit the products into the different parts of the pipeline, especially all flash performance is this link here. So with that, I want to thank everybody for attending and we'll see you next week.
Thanks, everybody. Thank you,
Thanks.
Paul.